In this video, we're going to look at this assignment that was over the squeeze theorem. So we want to show that the limit as x approaches 0 of x times cosine of 1 over x equals 0. Now you have to start with an inequality that you know to be true. So we know that cosine of anything is between -1 and 1. So cosine of 1 over x, which is part of what I'm trying to find the limit of, we can say is between -1 and 1. Now, instead of multiplying all three sides of this inequality by plane x, you have to remember that x might be negative, right? For negative values of x is negative. So if you multiply an inequality by a negative number, that causes a problem with the direction of the inequality sign. So we need to be careful here. In the middle, we can go ahead and multiply by straight x right here, but I want to make sure that on the left side of that, I keep it positive. So I'm going to put absolute value bars around the x. So we have the negative of the absolute value of x is less than or equal to x times cosine of 1 over x, which is always less than or equal to the absolute value of x. And graphically, you can see here that this is the graph of y equals the absolute value of x is always greater than or equal to cosine of 1 over x. And then here is y equals, right here, negative of the absolute value of x. So you can visually see that it is always less than or equal to x. Now if you don't put the absolute value bars, then you would have y equals x, which is the line, if you follow my mouse, that's the line that would go like this, y equals x, which is less than the function over there, but then above the function over here. So this inequality is not correct if you just put negative x, less than or equal to x cosine of 1 over x, less than or equal to x. Now you also have to show that the limit as x approaches 0 of your upper function and lower function, which are these two right here, are both 0, which is fairly straightforward, right? So therefore, by the squeeze theorem, because this function is always in between this upper and lower function, and those limits are both 0 at 0, the limit of our function is also 0.